Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 2568 that says minimum impossible OR. So this OR here states it's a bitwise OR. Okay. So here you are given one zero index integer array nums, and you need to find some x that is inexpressible. So this is what expressible and inexpressible is defined here. So let me explain you in simple terms that x is expressible if x is possible by taking bitwise OR of any numbers of this nums array. Okay, if by taking bitwise OR of some of the numbers of this nums array you can produce x, then we can say x is expressible, correct? And we need to return the positive non-zero integer that is not expressible from nums. That means the smallest positive integer that cannot be formed by taking XOR of the elements of nums. Simple. So yeah, if you look at this first example, that here you are given nums array 2 comma 1. So here, so let's try to produce how many different positive integers possible. So if you think of 1, yeah, 1 is itself there, it is possible. 2 is itself present. Okay. Now if you try to think of 3, positive integer 3, is 3 possible? Yeah, if you take an XOR of 2 and 1, you will get 3. But if you try to produce 4, then it is not possible to produce 4 by taking bitwise OR of the elements. Okay. So that's the reason that we return 4, because it is the smallest non-zero integer that is not expressible. That means it cannot be formed by taking bitwise OR of some or all the elements of this nums array. Now if you take a look at this example, so initially we start by trying to produce 1. Is 1 is possible? No, 1 is not possible. So we directly return 1 and we not check for other elements. Okay. So now before moving ahead, I want to show you something, that in order to produce elements, what other elements are required. So let's say if you have 1 comma 2, so with this element what other elements you can produce? You can produce 1 2 and 3. Okay, 3 is what bitwise OR of 1 and 2. If you have 1 2 4, then with that you can produce 1 2 3 4 5 and 6 and 7. See, if you see that 2 comma 3 means, sorry, not 3, 1 comma 2 means bitwise of 1 and 2 will produce 3. Okay, now 4 is itself there. Now if you take bitwise of 1 comma 4, you will produce 5. If you take bitwise of 2 comma 4, you will produce 6. And if you take bitwise OR of 1 2 and 4, you will produce 7. Got it? Now if you have some elements like 1 2 4 and 8, see, these all elements will be produced. Okay, now apart from that you will be able to produce 9 10 11 12 13 14 15. Okay, till 15, but not 16. Okay, so if you will check that how you will produce it, then you can try taking bitwise OR of some of the elements like 1 and 8. 1 and 8 will produce 9, then 2 and 8 will produce 10. So similarly you will be able to produce all the elements, or sorry, all the numbers up till 15, from 1 to 15, but not 16. So as you can see here, there is some pattern that if you have numbers like 1 2 4, then with these numbers you can produce all the elements up till 8 minus 1, all the elements. Okay, if you have 1 2 4 8, you can produce all the elements up till 16 minus 1. Got it? So yeah, if you have, so what is this? This is just the repeating elements of the powers of 2. Okay, so this is 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. And up till, let's say you have up till you have 2 to the power n. So with these elements, means if you have all the numbers from 2 to the power 0 to 2 to the power n, then you can produce all the numbers starting from 1 up till 2 to the power n plus 1 minus 1. See, you can produce all these numbers. Okay, so as you can see here, if you have 2 to the power 3, then you can produce 2 to the power 4 minus 1 numbers. So that is all numbers up till 15, correct? Right? And not 16, right? Not 2 to the power 4. So this is the equation, that if you have all the numbers from 2 to the power 0 up till 2 to the power n, then you can produce all the numbers, right, from 1 to 2 to the power n plus 1 minus 1. Okay, so here what we need to check is 1 present, is 2 present, is next, the next power is 4 8 16. Okay, is this power present or not? And the first power that is not present would be our answer. So let's say you have some sequence like 1 2 6, like 8 7 6 5 16. So yeah, but you okay, so this is the given nums array, but here is 4 present? No, 4 is not present, so our answer is 4. So we need to find first missing 2 power of 2. What? First missing power of 2, correct? So yeah, that would be our answer, because power of 2 is not possible by taking bitwise OR of any elements. Like if you want to produce 4, then it's not possible by taking bitwise OR of 6 or 2 or 8 or 1. It is not possible to take to produce 4, correct? So yeah, you need all the powers of 4 or the powers of 2. So that's why the first missing power of 2 would be our answer. Simple as that. So yeah, this is how, based on this intuition that if you have 1 2, then you produce up to this up to all the elements up to 4 but not 4, 1 to 4, then up to 7, 1 to 4 8, then up to 15. So based on this intuition, we have derived this solution that the first missing power of 2 would be our answer. So based on the above intuition, I hope you guys understood what we are talking here about. And now coding for this thing is simple as it is. Yeah, what we need to do, we need to just check if the power of 2 is present in the nums array or not. So yeah, I first took one unordered map u, and I checked for all the powers, like for all the answers. So initial as the answer is 1, so you can take this as a power of 2. So yeah, 2 power 0 is 1, so I started by 1 and I keep on multiplying by 2. And whenever I first encountered any power of 2 that is not present, so its frequency is 0 in this nums array, I simply return that, correct? Simple as that. So yeah, this was the case. So every time it will somehow hit this condition, and this will never happen. Okay. So yeah, that's for the coding here. It's as simple as that. And now talking about the time and space complexity. So yeah, as you can see that here I am storing all the numbers of nums array. So the space complexity is big of n, and the time complexity is also, you can say, big of n, as I am traversing for all the n elements. So yeah, that's for the time and space complexity. So that's all for this video. I hope you guys understood the intuition, the approach, as well as the coding here. And if you still any doubts, then do let me in the comment section. Make sure to like this video and subscribe to our channel. Thank you.